Hi everyone, today we're going to be sketching a linear graph using the gradient intercept method. So I've got a linear equation here, y equals 2x minus 1, and that's all the information we're given, that's all the information we actually need for this. So from this equation we can identify a few things. I'll write it over here. Firstly, we can identify the gradient, and the gradient is m, and our gradient for this particular equation is 2. Now, we can rewrite that as 2 over 1 as a fraction, and that's going to be important for when we go to find our second coordinate. And just while we're touching on the gradient, we know that the gradient is the rise over run. So I'm just going to put in brackets over here. This is the rise over the run. Okay. We're just going to keep that separate for now. So that's the first thing we know. The second thing we know is a coordinate. And specifically the coordinate that we can use for this is going to be the y-intercept. So the y-intercept always occurs when x equals 0. So if I've got y equals 2x minus 1 and I let x equals 0, my equation is going to be y equals 2 times 0 minus 1. Well, 2 times 0 is just 0, so I'll write that here. So we're just going, 0 minus 1 is just the same thing as y equals negative 1. So my coordinate, using that value and using this value as well, my coordinate then is going to be the point 0, negative 1. So that's going to be our first coordinate that we can draw in on our Cartesian plane over here. So I'm going to use, let's do negative 1, negative 2, negative 3, negative 4, and let's draw it in a different color. So I'm going to just plot that coordinate that we just found, the y-intercept of 0, negative 1. So that would be this coordinate in blue. And while we're here, I may as well just do some more. This is going to be positive 1, 2, 3, and 4. And we may as well do these ones as well. 1, 2, 3, 4. And just for good measure, let's do negative 1, negative 2, negative 3, and negative 4. Okay. Second thing, we are going to use our gradient to figure out our next coordinate. So let me do that in purple. So if our gradient is rise over run, and we know up in our first step that our rise is 2 and our run is 1, then from my first coordinate of 0, negative 1, we're going to be running 1 unit. So I'm going to do that first. We're going to just be running 1 unit out to from 0 out to 1, and we're going to be rising 2 units. So we're going from negative 1, now we're rising, that would be rising 1 unit, now we are rising 2 units, and we've stopped right at this coordinate here. That is going to be the coordinate 1, 1. Okay, so we're starting at our first coordinate of 0, negative 1. We're running, so we're going in the x-axis, and we're going to the right-hand side because the values are positive up over here. This 1 is a positive 1, that's why we're going out to the right-hand side. And we're going up 2 units. Again, we're going up because it's a positive. Okay, if it was -2, then we would still go out 1 horizontally to the right, but then we would be going down 2 rather than up. So that's why we're going up. Okay, now we've got our 2 coordinates. The only thing we need to do now is I'll get my ruler out, and we just need to connect these 2 lines. So try and do it as accurately as you can, and let's see if this will work for me. This is going to be your line in here. Okay, let's get rid of that ruler. And final step, we're just going to label that. So I've got this line in blue, y equals 2x minus 1. So a quick recap, you're figuring out your y-intercept first, you're plotting that coordinate, you're using your gradient to figure out your next coordinate, you're plotting that on the Cartesian plane, and then you're drawing a straight line in between the 2 points. We know it's a straight line because in the original equation we have a linear equation because x is only to the power of 1. It's not x squared or x cubed or anything like that. So that is sketching a linear graph using the gradient intercept method.